Hello, everybody, and welcome to another session of me programming daily. Today, drakon renderer again. I wanted to show you what I came up with yesterday. So maybe you remember that I built this by hand during the last session. During this session today, we're going to talk a little bit about another approach that I used, and this is to inject valent points in more than one block if required, so that all icons are aligned. And I can already see that it could work, but there's a little bit to be explained. So in the approach one, we injected valent points in just one block so that all paths are of equal length, but only of the length of the longest path. So this works in some cases, especially for valent points that are injected at the top of the graph, but it doesn't work in the lower parts of the graph where icons could be aligned, but they aren't. Some of them are, like icon 15 and 15 here, 16, 16 here, 12 and 12 here. But ideally, they should all be aligned on one level where they belong. So in the approach 2, and I need to reword this a little bit, but I did reword this on GitHub. You know what? Let's actually go to GitHub. I did reword it on GitHub. And it is here. These are the new rules. So our objective is to, I changed the rules a little bit. So the objective is now to align all the icons to have the same value in every path. And if some icons are missing and cannot be aligned, we inject a valent point. This works pretty well, and you can see that injecting 2 valent points here, 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 and here allowed the icon number 6 to be aligned. But it also produces paths that are longer than the initially provided paths. So in the previous example, we have the longest path going from 1 to 100, and I believe it only had like 10 elements. 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13. This one has, I believe, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, because we injected 3 valent points here. And basically, all paths at some stage get valent points injected. Now, just to make things clear, we're getting closer to canonical drakon here. But if we followed this religiously, what this chart produced, we would end up with graphs that are unnecessarily long. We can make them compressed, and I do believe I can come up with an algorithm that will allow me to compress those paths into something more presentable, more closer aligned with drakon principles. For now, though, I'm pretty happy with this because the algorithm of producing these injected valent points does not seem to be super crazy. But I'll probably swallow my own words very soon. So the plan I have for this session, if I have the time, is to try and come up with an algorithm that injects those valent points where needed and shifts paths around. So here, the first thing that we need to do is print the paths. And this is, by the way, the main branch. Maybe I shouldn't be using the main branch, but hey. Print the paths, not necessarily with the valent points. we're only interested in paths. And here, this does not have to be all convergence icons. This can just be would it be last convergence icon? Let's do this. So convergence icons, we can do last convergence icon. Okay. I think this is going to work. I hope. No, of course I'm not printing it, so what did I expect? This should produce a very long list, which we're not going to format too religiously, but I am going to open something. This. So these are the paths generated by the algorithm a while ago. I just want to make sure that we're still looking at the same thing. I'm not going to verify all paths. I just want to start drafting the new function that would inject valent points. So 112, 11, 10, 9, 8. Yeah, I think with a good degree of confidence we can say that this is it. So the function that we would need in order to achieve this result would look something like this. Let's call it the classic ABC. And this is all paths. So the way I think it should work is that since we are going to be generating elements, of the array, of the list, I think we can just use a fold. And here, thought we could no, paths. This function that we use here, DC paths, should ideally produce those paths in the reversed order. Oh, I'm getting ahead of myself. So first of all, let's just return a very simple list of ints. That returns simply lengths of all paths. So those lengths should correspond to what we see here in the original list. So I think this is 12, 10, 10, 13, 12, and so on and so on. Let's see if this builds. But before I do, let's not worry about these paths anymore. And here, okay. So we just did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Interesting. Oh, the order is reversed, obviously. Now, so this is where the challenge starts. Okay, so this fold goes through column by column by column by column. Okay, so what we need to do in the inner fold here is go through. Oh no, that's not going to be right. So what I wanted to do is this fold goes column by column by column by column, but here I don't need access to all elements of a column. I only care about specific indices of every column. So let me quickly change this from all paths to just a 0. And the inner fold here that would be iterating through all paths. Let's call it single index or I. And this is going to be single column or single path. So here we want to index single path. I don't usually do this, so let's see. Okay. This is a nice answer. I've been meaning to check out lens for a while now. I need to add it to my list, but for now, so single path. And now we can say icon. So obviously this is going to produce, 8 elements in the list. All elements would be of the same value, and it's just going to be icon 1, I hope. ACC2. So ACC1, since this will produce a list, let's just not do anything with the ACC1. Oh, sorry. No, I think we should. Yes. Okay. Oh, this is because we're addressing those paths from 100. So DC paths, ideally we should be producing DC paths in a reversed way. Okay, so let's park it here. We know the result is good. We just need to invert how we produce the paths. It shouldn't be 112. It should be all reversed. Let's hope it works. No. This is good. But they're in the wrong order. Oh, that's a head of single row. Let's quickly check if this works. What is the function for inverting lists? reverse. That is still not correct. I'll have to figure this out off camera. But for now, I think my direction is clear to try and produce arrays like that using code. Right. Pretty short session today, but I still thank you for sticking here with me and for your patience. I hope you see some more action and more results during future sessions. But I'm pretty optimistic that the direction that we have is pretty promising for easy layout, for easy connections, and easy maintenance. Thanks very much, everybody, and have a great day.